We will start. Good afternoon, everyone. Today, in this lecture, we are going to see the reverse tunneling that is used in the mobile IP concept. Okay, so if you remember in the previous lectures, we have seen what is tunneling now, and we have also seen how tunnel starts at the home agent and it ends at the foreign agent. Okay, so that is tunnel created by a home agent and it is ended at the foreign agent. Okay, so now this tunneling is achieved by encapsulation that we have seen. Now we will see what is exactly reverse tunneling and why it is required in mobile IP. Okay, so now when a mobile node moves from a home network to a foreign network, usually tunnels are required. So when packets are to be delivered to the mobile node, these tunnels are used for delivering the packets to the mobile node in a foreign network. Okay, so now when packets are to be written from the mobile node to the correspondent node, how it will performed. Okay, so as we have seen in the IP packet delivery, when packets are written from mobile node to the correspondent node, they don't have to go through the exact the same route as it returned from mobile node to the correspondent node. Okay, they don't have to go through the exact same route as it has traveled while delivering the packet to the mobile node. That means, suppose if we consider pictorially, suppose यहाँ पे CN है समझो, this is my CN, that is correspondent node. Okay, यहाँ पे मैं निकालता हूँ that is HN, that is home network, and somewhere here it is foreign network है समझो. ठीक है, so initially if you remember हमने क्या देखा था कि CN, if it has to, suppose mobile node is present in a foreign network, यहाँ पे अगर मोबाइल नोड प्रेजेंट है तो कम्युनिकेशन कैसे होता था, CN हैज टू send packet to the home network, that is home agent, then home agent will forward that packet to the mobile node in a foreign network. ठीक है, तो उसके लिए it was creating a tunnel and all that. Okay, but now while packet और जो रिवर्स कम्युनिकेशन जो होता था फ्रॉम मोबाइल नोड टू द करस्पॉन्डेंट नोड, इट नीड नॉट टू गो टू द होम नेटवर्क, इंस्टेड it can directly send a packet to the correspondent node. Okay, so suppose ये मेरा home network है, ये मेरा foreign network है, and mobile node is in the foreign network. Okay, so when mobile node wants to send a packet to the correspondent node, it directly can send a packet, okay, via internet to the correspondent node. Okay, now at first if you see, or at first glance, this is a written path for the from the mobile node to the correspondent node. It seems quite simple. Okay, but it is not like that. Okay, since why it is not going through the home agent here, because when mobile node has to send a packet to the correspondent node, destination address is stationary one, so you don't need a tunnel or mobile IP in that particular case. So that's why we can follow the simple path. Okay, but at first it seems quite simple, but it is not actually simple. Okay, the mobile node can directly send packets to CN as in any other standard IP situation, because CN is stationary, that is correspondent node, so it doesn't require any mobile IP mechanism. As I said, the destination address in this case will be that of a CN for all the packets that are sent to the CN. But there are several issues with the simple solution. So some of these issues we have previously discussed also during the IP packet delivery. Okay, so now we will revise them and see why reverse tunneling is needed and to overcome these particular issues. Okay, for that we will see the next slide. So the first issue, when the packets are to be sent from mobile node towards the correspondent node, in the present intranet will deploy a firewall at the foreign agent. Okay, so because most of the information or all of the information exchanged by the company within the network or outside the network has to be kept confidential. Okay, so in order to avoid any intruder or hijacker to hijack the information, firewalls are implemented at the foreign agent. Okay, so these firewalls are used for filtering out the malicious addresses from administrator point of view. Okay, so if we talk about the general scenario, suppose scenario kaisa hai dekho, suppose this is my foreign network. Okay, this is my foreign network. Okay, यहाँ पे मेरा foreign agent है समझो, that is I am having foreign agent over here. Okay, then इसके आगे I'll have the firewall. Okay, so whatever packets coming to this particular network, okay, will go through the firewall, and coming out of this network will also go through the firewall. Okay, so how to avoid intruders from hijacking your information as it is going through the firewall? Okay, so your firewall will filter out any addresses which are not part of the company site network. Okay, so now any home addresses, that is important here, because when packets are originated from mobile node, their source address will be the address of mobile node. Okay, so even if they are stationary nodes like correspondent node in the foreign network, these packets will be filtered out or monitored through the firewall while they are delivered outside the network. Okay, so quite often firewall only allows packets with topologically correct address. What is topologically correct address? Topologically correct address means whenever you are a part of a network, suppose let's say this is a foreign network. Okay, that means we have certain subnet address given to that particular network. Okay, so suppose that subnet address is something 130.40.0.0. Okay, all the nodes which are present inside this particular network will going to have the same address or belonging to the same subnet starting with 130.40 dot 130.40 dot so on. Okay, so if mobile node is a part of this network, it will have a IP address which belongs to the home network. So it may be anything, suppose 192 or 192.32, anything. Okay, so is not a part of this particular subnet. Okay, so what firewall will do in that case, so it will recognize that the source address of this particular packet does not belong to any of the node, okay, belonging in the network, and it will filter out the particular packet. Okay, so now this happens because mobile node is using its own IP address as a source address while sending out the packet. Okay, so now why firewall is doing this or implementing these rules? Because it does not consider the presence of the mobile node inside the or inside of the network. So it considered that whatever nodes which are present or which are present in the network are all belong to the same subnet. Okay, so if any address which is not belonging to this particular subnet is trying to send a packet, it must be an intruder, and that's why it filters out the packets sent by the address which is not belonging to the subnet. Okay, so this provides a least simple protection against the misconfigured system of unknown addresses. So as I said, this is for simply filtering out the intruders based on the source addresses. Okay, so as firewall is not considering mobile nodes part of the foreign network, so this problem is always observed in the foreign sites networks. So however, MN still sends a packet with its fixed address as a source, which which is not topologically correct in the foreign network. So that's why it is said, or it is said as it is not topologically correct, because this address does not belong to the subnet. As you can see, it is starting with 196, sorry, 192, and the subnet is starting with 132.40.0.0. Okay, so that's why firewall may cause an issue when a mobile node moves into the foreign network. Okay, so mobile node may not be able to send out any message to the correspondent node which is outside of the foreign network. Okay, so that is what the one particular problem. Okay, then there will be the another problem. Okay, so then there will be the another problem. Suppose uh, in the case, the second problem is that is multicast. Okay, now nodes in the home network might participate in a multicast group. Okay, now what is multicast group? We have already seen what is multicast meaning. That means in a network there will be a certain nodes which forms a group. So whatever packets which are sent to this particular group will be delivered to all the nodes in the group. So if you remember, we have seen that multicast group in a particular network, there are certain number of nodes which forms a multicast group. Okay, so whatever packets will which are sent to this particular group will be delivered to all the nodes. Okay, so there is a group ID associated with each multicast group, and this group ID is, so each multicast group will be having one group ID, and that is used as a destination address when delivering packets to any of the nodes within that particular group. Okay, so if you have to send any packets to one particular node of multicast group, you have to use group ID as a destination address, so that packet will be delivered to all nodes in the multicast group. Okay, or when you have to send any packet from this particular multicast group towards the destination, then again source address will be used as a group ID. Okay, or group ID will be used as a source address. Okay, so now when a node is a part of a such multicast group, MN in foreign network cannot be a part of such multicast group. Now if there is a group which is formed in the home network, suppose, तो एक पर्टिकुलर होम नेटवर्क में एक मल्टीकास्ट ग्रुप अवेलेबल है. Okay, now let's say this is a particular group and this is available in the home network, and suppose one node is moved out and goes to the foreign network. Okay, now it cannot remain a part of this multicast group because these three are the part of this multicast group of a different subnet, and now though this particular mobile node has moved out, so this become now a part of different subnet. Okay, so MN cannot send a packet or multicast packet same way they used to send it through the home network. Okay, so in home network that is not an issue, but when it moves to the foreign network, they do not remain part of a multicast group anymore because of having a topologically incorrect address. Okay, so because once they move into the foreign network, they have to acquire a COA. So packets delivered to this group will be delivered to these three nodes only. Okay, but not to this node, because it is a part of a different subnet now. So COA will not be part of the same subnet used by the home network. That's why packets cannot be transmitted to a mobile node, or in the reverse direction also. Same thing will applies. Okay, why this happens? Because foreign networks might not even provide the technical infrastructure required for communication. Now, technical infrastructure means the multicast backbone network, which is required to support multicasting within the network. Okay, so in order to deploy or in order to implement multicasting in the network, that will require specific hardware which will be able to deliver packets to all the nodes within that same multicast group. So that multicast backbone or mbone, which is the infrastructure responsible for creating the multicast group and keeping track of all multicast groups, or keeping track of all the nodes within each group and then delivering the packets to each group. Okay, so that multicast backbone may not be part of foreign network, or they may not be supported by foreign network. So if it is not supported by the foreign network, then mobile node moving out of the moving out of the home network will not work, and mobile IP will also not work. Okay, so that is the second issue. Then the third issue is, first issue what we have seen for the first issue was the firewall, and the second issue was the multicasting. Okay, then third issue is a TTL. Okay, we all know what is the full form of TTL. That is nothing but the time to leave. It is a field used in the IP packet to indicate within how many hops the packet should be delivered to the destination. Okay, so if MN wants to send a packet with a certain TTL, okay, so let's say TTL is equal to, suppose TTL is equal to 5. Okay, now that means within 5 hops, the packet should be delivered to the destination. Okay, now it will work when mobile node is in the home network, because path is clear, already calculated by the home router or home agent. But if this TTL is low, so that the packet will not be transmitted outside that particular region. Okay, so that means if packet is, let's say, having a TTL of 5, okay, that means it can cover a distance of, let's say, 10 kilometer. So if it is covering the distance of 10 kilometer, okay, because there are routers which can carry this packet with this TTL up to only 10 kilometers. Okay, so now if mobile nodes moves to the foreign network, okay, so obviously this hop count is going to increase the distance between the mobile node, which is now in the foreign network, and the destination is now larger. Okay, so if TTL is not modified, then packet will not reach the destination. Okay, so that's what it is said. Now if the mobile node now moves into the foreign network, TTL might be too low for packets to reach the same node as before. Okay, so same destination cannot be reached with the same TTL. So if mobile node mostly in the foreign network, so if you have to modify this TTL, let's say now it has moved to the foreign network. Since it has moved, now it is sending the packet with the TTL equal to, suppose initially it was sending with 5. Now why mobile node will still send the packet with TTL equal to 5? Because mobile node feels that it is still part of the home network, because all the packets are still delivered to the mobile node, so it will keep the TTL to 5. Now what happened after sending the packet is a responsibility of the foreign agent and home agent, that is forming a tunnel. and making sure that packets are delivered. Okay, so now if we have to make this packet reach the destination, we have to increase the TTL. Okay, suppose we are using TTL as 5 plus 3. So modifying the TTL field during the transition or during the transit is not keeping the semantic of IP. If you are suppose if someone is trying to modify your TTL field, that means it is an intruder who is trying to deliver a packet somewhere. Okay, so whenever where source of the packet is not aiming to deliver the packet. Okay, so now if this TTL field is modified, that means someone is trying to deliver the same packet to somewhere else, which is beyond the destination. Okay, so because adding +3 means the packet should reach further distance beyond the initially specified by the mobile node, and that is not keeping the semantics of IP. So mobile IP is no longer transparent. Okay, so these are the three main issues which are observed in the mobile IP and in tunneling. So how to overcome these issues? Okay, the simple solution for this is use of tunneling, reverse tunneling. Okay, now all these issues led to the defining the reverse tunneling as an extension to the mobile IP. So what is exactly the reverse tunneling is, we are going to see. So we have already seen what is tunneling or what is tunnel. The tunnel start at one point and ends at one point. So initially what we have seen, tunnel was starting at home agent and ending at foreign agent. Okay, that was the normal tunneling. Okay, now what will happen in the reverse tunneling? Tunneling will again happen, but now the starting will be at the foreign agent and ending will be at the home agent. Okay, so mobile node, when it has to send the packet, tunnel will be created by the foreign agent and it will be terminated at the home agent. Okay, so same tunnel we are going to create, but in the reverse direction. That's why the name is reverse tunneling. Okay, so without reverse tunneling, packets used to be delivered directly via internet. That will not happen because of the issues we have just discussed. Okay, now what will happen? Mobile node will mobile node will initiate a packet, so it will be delivered to the foreign agent as you see in the particular step. Now once foreign agent receives the packet, so firewall is here. Outside the foreign agent, so outside because firewall is a protected from the outside world. So when packet reaches the foreign agent, it understand that the source of this packet is temporarily inside of the current network, so it will generate at tunnels taking care of address as a source address and destination address as a correspondent node address, and it will create a tunnel. Okay, so now tunnel will start here. Okay, and it will create a tunnel between the foreign agent to the home agent. Okay, because COA here, care of address, COA to IP address mapping is already present in the foreign agent, so it will create a tunnel between the foreign agent and the home agent. Okay, so that's you can see in the second step. Okay, packets are given back to the home agent. Now after home agent, once home agent going to receive the packet, it will understand that this packet has to be delivered to a corresponding or correspondent node whose path is already known, because already we have received packets from the correspondent node. Okay, and it will forward the packet to the correspondent node. So by this way we are creating a reverse tunnel between the foreign agent and the home agent. Okay, now this is slight modification to the normal simple solution for delivering the packet to the mobile node. from mobile node to the correspondent node. Okay, how this mechanism of reverse tunneling will solve the problem or issues just we have discussed, so like firewall, multicast, or DTL. So now let's see that one by one. So how it's solving the problem of the firewall, TTL, and multicasting. Suppose now router, as we know, accept only topologically correct addresses. Okay, so now because of the reverse tunneling, are we getting topologically correct address? Obviously yes, because a packet from the mobile node is now encapsulated by the foreign agent, and once it is encapsulated, source address becomes not the IP address of the mobile node, but it becomes the COA, that is care of address. Okay, so firewall will not block this COA because COA is a part of new subnet. Okay, that belongs to the foreign network. So COA belongs to the foreign network. So firewall will not block the COA. So destination address was never an issue for the firewall. Okay, so this problem is solved as of now. Okay, so furthermore, multicasting and TTL problem, these are also solved. Now how these are solved? Because of the reverse tunneling, we'll see. Now COA will be used as a source address, so multicast packets can also be sent by MN, because once home agent decapsulate the packet received at the home agent, then it understand that this packet is initiated by a node which is currently a part of multicast group, and it will be able to deliver the packet to the destination. Okay, now how reverse tunneling is helping? In this case, the foreign network does not need a multicast backbone, because multicasting is still supported by the home network, and it has to just decapsulate the packet sent by the foreign agent. Then the third issue was TTL. Now in the case of TTL, if you recall, in the case of tunneling, when tunnels are created, no matter how many routers are in between this tunnel, entire tunnel is considered as a one hop. So that packets are being initiated by the mobile node, this is considered as one hop and included in the TTL field. Okay, so even if it is far away from the home network, it will still be one hop away from the home agent. So home agent understand that this packet has come only within the distance of one hop from the mobile node. Okay, so it is correct one or correct TTL, so you don't have to change any TTL, and packets can be still delivered to the destination. Okay, so this is how it can be solved, or reverse tunneling can solve the problems or issues of firewall, TTL, and multicasting in the mobile IP. Okay, so this reverse tunneling standard is also specified in the mobile IP. So this standard is backward compatible. Okay, so that means this extension can be implemented easily. You don't have to change anything which is already in existence, and it can cooperate with the current implementation without these extensions also. Okay, so it is just an additional part which you have to attach if you need reverse tunneling or not, that you have to just specify. Okay, the standard is not complete overall of the existing standard. So we have seen during the agent advertisement message format, we have seen, so there was one flag which indicated as R, capital R, which requires the node regarding whether they want reverse tunneling or not. Okay, so if the R is mentioned as 1, so that means reverse tunneling is expected by the agent. So by simply mentioning this R value as 1, you can request mobile node for supporting the reverse tunneling also. Okay, so although it looks bit simple to solve this problem in the reverse tunneling, there are still some issues. Suppose for example, in the case of firewall, we have just seen that reverse tunneling may solve the issue of firewall, but there are some issues like reverse tunnel can be abused to some circumstances, security mechanism. Okay, since packets are coming from foreign agent, so there is a concept called as a tunnel hijacking, if you have heard about it. So we have several times observed in the information security or cyber security where intruder hijacks the tunnel. That means listens to the packets from the tunnel and receives information regarding the source of the packet. Okay. Now, if it is done, then whatever information which is confidential inside this network, that will be revealed to the intruder, and that is not intended by the firewall present in the foreign agent. Okay. So if this tunnel is hijacked, then intruder might know information about the company site. Okay, so that is one issue. Then reverse tunneling also create triangular routing problem. Okay, so the data paths may create a triangular routing problem. So what is triangular routing problem? Suppose for example, uh, suppose correspondent node है, okay, एक home network है, okay, and suppose this is a foreign network, home network, correspondent node. Okay, now in the foreign network, mobile node has to move from this home network to the foreign network. Okay, and it has to send a packet to a correspondent node which is already in the foreign network. Okay, now what is the triangular routing problem? Or in this case, we said it is a double triangle. First we will see what is the triangular routing, then what is double triangular routing we will see. So let's talk about the triangular routing. Now correspondent node, when sends a packet, so it travels this direction towards the internet. Okay, now if mobile node moves to this particular network instead of this foreign network, so mobile node and the corresponding node are in the same network. So in that case, let me clear this. This is the correspondent node, and this is the home network. Suppose so, mobile node has more from home network to this network. What is triangular routing? So CN, correspondent node, sends a packet. It travels through the internet, reaches home agent. Now home agent understand that this mobile node has moved to the foreign network. Okay, which turns out to the same network as that of CN. So it resend the packet back to the same network. Okay. So even if correspondent node and the mobile node are part of the same network, still the packet has traveled entire back to the same network. Okay. So even if correspondent node and the mobile node are part of the same network, still the packet has traveled entire distance of internet. Okay, home agent, from internet it reaches to the home agent and again back to the same network. So this creates a triangle. Okay, so that is called as a triangular routing problem. Okay, what is double triangular routing problem? Now when you visit a foreign network of a company site, let's say this is the foreign network. Okay, mobile node and correspondent node are the part of this foreign network, and there is a tunnel already present from home agent to the foreign agent. So same triangular routing is created in this direction, and then same way we created in the reverse direction. Okay, so this is the triangular route. So while sending the packet from CN to MN, triangular routing problem occurs. While sending the packet from mobile node to the CN, the triangular routing problem occurs again. So that is the double triangular routing. Okay, so reverse tunneling does not solve this particular problem. So simple example of the this triangular routing can be pursued in India, is calling to a person who is a resident of US, but it is currently moves to India. So suppose if a person in India is calling to the person in India, it should be a direct call. Okay, but because of this person which is currently now in India but is a citizen of US, or he has a SIM card of the United States, so call will go to the through the US, and again from US it will come back to the India, and to us again back to the India. So this is nothing but the triangular routing. That means if mobile node and correspondent node, if they are present in the same network, then still the same procedure of tunneling is happening and triangular routing problem is created. Okay, so this is nothing but the triangular routing. The call should not be gone to us because caller and callee, if both are in the same network, if they are present in the same network, so that is the simple example of triangular routing. So the reverse tunneling does not solve this problem, but still it provides the many other problems, solution for many other problems. So it should be implemented while implementing the mobile IP. But the only problem is problem of triangular routing that will remain as it is. So there is we don't have any solution for that triangular IP. So that is the only problem remains with the reverse tunneling. Otherwise, reverse tunneling is solving the problem of firewall. It is solving the problem of TTL. Also, it is solving the problem of multicast group also. Okay.